Hi everyone, my name is Jannik. I work at Shutter Network, and what we do is we build encrypted mempools. Now, some time ago, everyone started talking about intents, and everyone was very excited because you can do many cool things with them, and I guess that's the reason why many of you are here. And we were very excited as well, and we were trying to figure out how this thing that we built, encrypted mempools, fit together with intents, and if they fit together at all, if they maybe clash, and how they can be combined potentially. And this is basically what I want to discuss now. To start, I think it makes sense to start with the MEV supply chain, this model that Flashbots came up with to describe how basically blocks are built and MEV is extracted. It starts with the user who has the intent to do something, and it tells it to the wallet, and the wallet transforms this fuzzy intent into a concrete transaction, still locally on the user's machine usually. Then this transaction will be sent either in public or in private to a searcher. The searcher will try to earn money, extract MEV by backrunning it, front-running it, whatever they can. And then build a bundle out of this transaction, maybe others they combined it with, send it to the builder who will assemble a block that the validator will then sign, and then after all these steps it will finally end up in the chain. Now an encrypted mempool basically tries to be a shortcut. It tries to cut off all these middlemen, the searcher, the builder, and the validator. It tries to get the transaction directly into the chain. Why? Because in many cases, in particular what the searcher does is not in the interest of the user. Like, users don't like to be front run. So if we can kind of circumvent the searcher on this way, the user benefits. One way to implement this, there are many ways. I think 2 talks ago we saw you can implement something like this with time lock puzzles. And the way we do it is using threshold encryption. So we have a committee of nodes. This committee produces keys, encryption keys. Users can take these keys and use them to encrypt their transactions. The chain then has to accept these encrypted transactions into their block, so that they are ordered and sequenced in one particular order. And once this order is final, this threshold committee can collectively produce the decryption keys. Using these keys, now the chain can decrypt the transactions and finally execute them. This means that since the transaction is encrypted, even if the searcher gets access to it, it doesn't know what it does. It doesn't know if it buys a token, if it sells a token, which token it is. Maybe it's doing something completely different. So it's very difficult for them to extract MEV from it. And as a nice side effect, it also increases censorship resistance, because in particular the proposer might not like certain types of transactions, maybe transactions that use a particular contract. But if the proposer doesn't see which contract this transaction is interacting with, they can't effectively censor it. Right, this was about encrypted mempools. Now intents in this MEV supply chain. Now, in the traditional model we discussed earlier, the intent of the user was translated by the wallet into a transaction. Now in this new, more fancy, more powerful maybe model, it will be done at a later step by something like the searcher or a builder or a solver. The idea there is that the searcher has access to more information. They can collect like multiple intents by multiple users and can combine them. And build more efficient blocks using this way. Now we can already see where there might be a problem. So if the point of encrypted mempools is to circumvent the searcher and other entities, but for intent matching we need the searcher, then these kind of obviously don't go well with each other. So yeah, that's basically what worried us a little bit, and then we started thinking, are there ways to resolve this conflict? And it's not, we're not done with that analysis yet, but where we are right now is we came up with basically 3 potential solutions. The first one is not really a solution at all, but it's kind of we realized it's not necessarily a problem at all. If we can have maybe both of these technologies living side by side, and they could coexist potentially. This would make sense if there are, so there's probably two groups of people, one users that benefit from encrypted mempools, another one that benefits from intent matching, and they might, or they probably overlap. But there's also some of these users which are only in one of these circles. For example, there might be users who want to use protocols that are being censored, and they might benefit from encrypted mempools, but they might not benefit from intent matching at all. So they might only use, they are very happy with using encrypted mempools if the technology exists. And then there's maybe other users like a certain types of traders who benefit a lot from intent matching, but they don't care about encrypted mempools. They don't need them. And then in these cases, we could see that these technologies could coexist. And I think that's true, but I don't think that the overlap or that this that is going to be a lot of users. I think the overlap between the benefits or users benefiting from both technologies at the same time is actually quite big, because it's mostly, like most of the intent matching system we've seen so far is about trading and exchanges. And that's also the main use case of encrypted mempools. Like, we want to protect users from front running. This is mostly affecting traders. So not a complete solution, but something I think to keep in mind. Now, the second thing is what we call post-inclusion ordering. It's very similar to, if maybe you've heard of that in the Cosmos ecosystem, protocol-owned builders. The idea is that we could do the intents matching on-chain. This means that instead of having this intent matching step kind of in this fuzzy peer-to-peer world where there's no commitments yet, we could do it later. We could first write these intents directly to the chain, similar to how we write transactions today to the chain, and only then match them afterwards, either using some sort of hard-coded algorithm in a smart contract, or using some auction model, or a combination of those. Maybe an algorithm that constrains an auction. For example, you could make sure in this auction that all intents that are have been committed to the chain are considered. That at this step no censorship can happen anymore, or that all intents have to be treated equally. That they, for example, in an exchange type application, that they have to get the same price. And if we do that, if one would build such a system, then this would mean that you can send the intent in encrypted form. So you could use an encrypted mempool to get your intent on chain. And then you would get kind of benefits of both worlds. In particular, you would get censorship resistance, which you probably don't get in at the moment. Of course, this has some drawbacks as well. Mostly, it's less efficient, because if there's intents that you can't match for some reason, maybe they ask for a price that is unreasonable, they would still end on chain, and you would probably have to pay a transaction fee for that, which you don't like. And it might also reduce the user experience a little bit, because at the moment you can do intents, for example, you don't have to pay a transaction fee in many intent systems. For this you would, or at least someone would have to pay a fee, of course. Yes, and the last way that we came up with how encrypted mempools and intent systems can be combined is this. Basically, at some point, the searcher or the solver so basically we can use it to not protect the user from front running, but we can protect the searcher or the solver. We can allow the searcher to use an encrypted mempool to get kind of the solution that they found into the chain. And arguably, they're much more interested in this than a typical user, because there's usually a lot of value in these solutions. Of course, it's kind of their job for a solver to find a good, to match the intents in a very good way. And if now someone else would see the solution and they could just copy it, could just steal it, then they would not make any money out of it. So in a way, they have to be protected very strongly, and an encrypted mempool might be a good solution to do that. Yeah, that's basically all I have. Maybe to summarize a little bit, it seems that encrypted mempools And intent matching systems are fundamentally at odds because of, if you remember the picture that I showed. But it seems also likely that the two will coexist because there's different groups of users who benefit differently from these two technologies. And there's also ways to combine them in one system actually using either post-inclusion ordering and or allowing searchers and solvers to use them. That's all from me. I'm not sure if we have time for questions. Probably not because we're behind schedule. But if not, just find me afterwards.